I'm Andrew again, and I was looking over the video for this experiment, um, Planck's constant and work functions, and I realized that there was a small addition that I made last spring, to the procedure as I was editing it, and so I thought I'd show you a little bit more. So let's go ahead and fade over to the worksheet. And here's the worksheet right here, and here's my results for gold. Yes, I know I needed to put in the chart title. And here's my results for sodium right here. Oops, I'm just right on top of it. There's my results for sodium. Now, in the new procedure, you also have to do two more tabs for unknown 1, or unknown, and then unknown 2. And so here's unknown and unknown 2. Now, I just want to point out right here that my unknown 2, even though there are values in a work function table that are closer to this number, I still chose this 4.7 based on the color of the cathode. Or wait, sorry, it's the anode. The color of the anode. Oh, it's one or the other in the photoelectric effect applet. So, so this is the expected value. Next, we have to do a weighted average to find Planck's constant, our experimental value. Here's our expected value with a couple more digits if you look up there in that corner. But I have to do a couple more calculations. And so to do that, I have this results sheet right here, and I already have all the headers typed up and everything. Now, I just want to point out where that's coming from is in the discussion. It gives a nice example how to do the weighted average. If you look at these experimental results, they all have different uncertainty. And so you can't just do the simple average. You have to do the weighted average. And if you scroll down just a little bit, the formula for the weighted average looks a little bit complicated. We've done it once before, or maybe twice before, and we'll be looking at it again today. And then the uncertainty of the weighted average, or the standard error of the weighted average, is this formula right here. So let's just start out by typing in sample in all these things across the top. And then we'll use two more cells for the weighted average, or I'm going to say the WAV, or wave, and then the SE of the weighted average, or the error of the weighted average. So let's go back over to our worksheet really quick. And so I'm going to go first with sodium, and I'm going to copy the two results. Notice how I rounded these values, because this one's a rule of 1 and 2, so I rounded it to a 3, and I kept this one with two digits after, because that would be the same digit as the 17. So Control C, and go over to results, right click, value paste. Next, let's go to do the same thing for gold. And your numbers should look different than mine because you took different points of data than I did. And remember, there's not an exact answer in science. When you take measurements, the measurements are always going to be a little bit different. So here's unknown 1, value paste, and I'm going to go to unknown 2 and do the same thing. Results. Oops, Control Z, right click, value paste, or Control click, value paste, or two finger click, value paste if you're on a Mac. Okay, so next, what does this MI over SI squared mean? It means my measurement divided by my uncertainty squared, and then just copy it down the column. So that's going to equal this value divided by this value, quantity squared. And just copy it down the value column. Now I'm going from negative 15s to and negative 17s to positive 18s, but it's okay. That's just how the formula works. And matrix mathematics can actually get some pretty big exponents. Next, I'm going to do 1 equals 1 divided by the uncertainty squared. And when you see this number, you're going to say, wow, that's even a bigger number. Yes, it is. Okay, so now let's go back to our sheet really quick. So now it says, now that we have those two columns, we have to equals the sum of this column, or column D, divided by the sum, actually in my case, It says C and D, but in my case, it's going to be D and E because my results is over in that column. So I'll have to make that edit. Okay, so that's pretty easy. I'm just going to equals SUM and this column divided by sum of this column. Oops, I forgot the parenthesis. Yes. And so now my experimental weighted average of my Planck's constants that I measured in electron volts, I need to put in EV, electron volt seconds, is that value. I don't need to copy this one down the column because of this is the average of all these put together. Now the uncertainty of the weighted average, which also has the same unit, so I should probably put that in there. The capital VS is, let's go back to the sheet. The discussion is the square root of 1 over the sum of all those values. Okay, so that's easy enough. Equals SQRT 1 divided by sum of all these values right there. And one more parenthesis to close it off, and there I go. So in this case, because it's a 2, I have to round it to 2 digits, and then I have to add another digit over there. Now my expected is, I'm just going to go ahead and copy it from my other cell because of, I just copied this from Google. Yes, you can copy things like standard numbers from Google, but you can't copy answers. Okay, Control C. Nobody's going to argue what the value of Planck's constant is. Okay, so next, under Z. Z, remember, is just equal to ABS. This number minus this number. Oops, I accidentally typed in a Z there, divided by, I'll get that in just a second. I'm going to come back over here and edit that. So I get a z-score of 0.44. Now this z-score might not be the best value out of all my results, but it's not the worst either. It's an average of all my experimental data. And so you'd report all your results. You should probably just report this table over here. You know, make it fancy, make it bold, color, include that in your write-up, and then also include these results over here. Sorry, this whole set of results. And this is part 2 of Planck's constant. Thanks for watching.